everyone, welcome to tonight's live stream. We are live and it's Let's Create. This is a live show where we are going to recreate a mechanic from a famous video game as best we can within the hour that we have here. Now it usually ends up being like a prototype of some kind, but hopefully you get to learn and see various techniques for accomplishing something like what we're doing tonight. And what is that what we're doing? Well, we're taking a look at Hogwarts Legacy, and in particular, we're taking a part of that, which is the spells combat type system they've got going on in there. So that's what we're going to be doing today. So I'll be talking through the design process that I'm thinking of, and also some of the hurdles and challenges and things that we can figure out whilst we're making it. Well, what I want you to learn from all this is not just like the tools of how to make something like this, but more about the thinking process behind taking a mechanic that you see in an existing video game and converting it over to your game. And that's really what I want you to take away from today's live stream. So, yep, we'll be taking questions, everyone in chat. So, hello, everyone in chat. I sound muffled. Ooh. Is the mic broken? More mic. in touch with the mic, so hang on, let me double check that. Testing 1, 2. Why has that gone so quiet? Let me pull the music down a bit. Why is this? Let me know, is that working any better? I literally haven't touched the settings since last time, so I don't know what's happened there. Yeah. So testing, much better. Okay. Much better now. Okay, brilliant. That's weird. I didn't touch, literally have touched nothing since I've done that. I'll turn it down in here too. Let me check my levels. Yeah, why is it so low? That's curious. Hang on. Let's work out what's going on. Yeah. No cables are falling out. No. No point in me talking if you can't hear me. Hang on. I'll turn up the gain a bit. Let me know. Does that sound any better? Not getting too much background noise, hopefully. So I haven't changed any settings since the last time we were on live, so not a clue what's happened there. Let me know if you get too much background noise, like the fan of the computer and things like that. But hopefully we're good to go there. Yeah, sorry. I mean, the levels are looking better on my side now, which is more what I would expect. Sorry. Okay, so make sure we're not peaking too much. There we go. All right, let me know if there's any other issues with the sound. But yeah. So yeah, as I say, I wanted you to take from this the sort of process we're going to take about taking out a mechanic from a game and trying to just break it all apart and see what we like and what we want to do with it. So we want to take apart the if you've never played Hogwarts Legacy, there's a spell system in the game where combat is the spells, and the spells have a color associated to them based on what type of spell they are. But like physics based spell, fire based one, so on and so forth. So what is it? Why is this important? Well, enemies can have different shields around them, and you have to use the right spell against the right shield. So if you use a yellow one against a red shield, nothing would happen. They'll block that attack. So you have to keep switching your spells about and your tactics about to be able to combat these enemies. So that's what we're going to try and mimic today. Okay, so we're not worried about too much about AI characters walking about or anything like that. We're more about just like, can we cast different types of spells and react towards their spheres? Because we're only here for an hour. I very much doubt we'll be able to do much more than that. But we'll see how far we go. We never know. So to help with this, I have brought in an animation pack that I previously have had in my library. It's the caster animation pack. Whether this will be any good for us, I don't know. I have no idea. But it's more like with hands magic rather than wand magic. But it'll do. But first of all, I need to transfer all of these over to our UE5 mannequin. So I'm going to go into my animation folder here, and we're going to turn on animations. Why is it with seeing none? They were definitely just there a second ago. Why is not liking this animation? What? Alright, screw it. We won't do it with the filters. I don't know what's going on there then. Okay, so we've got casting and we've got some loops in here. We'll just do some casts we've got in here. We'll just take these ones for now. That'll do. I'm going to retarget them. And we'll just use the UE4 to UE5 mini retargeter. And I'll chuck it into my characters folder, animations, many. Okay. So nothing special there. Okay. Okay, so there's our animations. Right, so although they're looking a bit weird. Oh my dear. Oh, did I use the wrong retargeter? Whoops, I used the wrong retargeter. Retarget. UE4 to UE5. That's what I wanted to use. Animations. Money. Okay. Retarget. No, they're still breaking. What's going on? For some reason, the retargeter's breaking all these animations. And it shouldn't do. Something funny is going on here. Because... what the hell's going on? I mean, it's not the end of the world. We just don't have anything but animated, so it won't look as good, but... oh, they're already at UE5, mannequin. They're already UE5. Whoops, my bad. Yeah, just need to change the skeleton over to them. So just do that. Replace skeleton with this one. Cool. Yep, all good. Okay. Yeah, that was the issue. They're already UE5 skeletons. My bad. Okay, so we have got animations. Right, so first of all, we need to actually cast spells and things like that. So we've got these animations in here, so we're just going to make some a montage. We'll just do a point cast, right cast. Even though that looks a bit weird. What are these animations doing? And I'm going to re-import them back in. I'm confused about what's going on here. Yeah. If they're not going to work on this second add to the thing, we won't bother with animations. Project. Yep. No, these are definitely UE4 ones. Why is it showing UE5? I'm so confused. Hang on, the skeleton it's using there. Mannequin, SK mannequin. Okay, so they're... alright, okay, I'm confused. I don't think this pack's been made right. It looks weird. No, it looks okay, I guess. It's just, I don't know, something that looks off about it. Whatever, we'll use it. Okay, so we'll create a montage. And we'll do cast spell. We'll just do one for now. I'm not going to fuss about too much about it. And we'll go... everything just looks like a bit like broken. Don't know. Maybe they broke something about it. Anyway, there we go. So we want to notify when the spell should come out of their hand. We'll go for about there. Notifiers. Add notifier. Montage notifier. And compile that. Then I want to go to my player character, which is in a third person folder. And in here we're going to add the input for them to attack. So let's go to our inputs folder, which is in here. Just create a new action in here. Inputs, input action, IA, attack. If you, we'll also try and, if we want as well, try and map it to a controller, so we can do the whole thing where you have to hold down the right trigger and then hit the button, because that's the way it works. And control, you have to hold down the trigger and then hit X, Y, A, or B if you're using a controller. Yeah, so attack, modifiers, no, not modifiers, triggers, chord action. I think that's the right way to use. It must be triggering for this trigger. Yeah. So a chorded action means that you have to hold down another button when you push this button. So in here, we're going to create another input to say prepare spell, something like that. Prepare spell. So if you've ever played the game of controller, it's the right trigger sort of behavior. We don't have to do anything on this one. It's just on here. We tell it which one we want to be using, and that is going to be the prepare spell. And both of these will be digital ones. They're nothing special or digital. And we'll leave it like that. So on the third person character here, IA attack should only work when I'm holding down the trigger. So if I were to do a print string on here, say hello, let me turn on my controller, and let's go to the context. So here, to add it to the context, we'll add both of them to it. So IA attack, and that's going to be my face buttons. So I'm going to add A, and add another one, X, another one, Y, and finally B. New mapping for prepare spell, and this will be right trigger. I don't want to use the right trigger axis. I want to use just the right trigger. The difference between the two is the right trigger is a boolean, so it's going to be off or on, so you're either pushing it or you're not. Whereas axis is the analog value you're getting from the trigger. So the harder you squeeze it, the more value you're going to get out of it. But that's all we need from that, is just that. Okay, so save that. And let's see if this is working. Okay, so if I push A, B, X, Y, nothing happens. But if I hold down right trigger, fingers crossed, yay, it works. Okay, so I can only cast a spell from holding down the right trigger. So that's what's really nice about the enhanced input system, is it saves you a lot of that fiddly work that you were doing before with the old input system, as you can do lots of modifiers and triggers like that. So pretty neat. Saves us a bit of effort. Okay, so there's that thing. Right, so we're going to cast an attack. And we'll do it on the started of this. So triggered basically means, if I were to rephrase it, so triggered is basically whilst you're holding the key down. Okay, so if it's being pressed, what it is. Whereas started is when you've first pushed the button, and complete is when you let go of the button. Cancelled and ongoing change depending on what kind of modifier you're doing to it. But ongoing is similar to what triggered is. It's just it basically whilst it's in between start and stopping it. Whereas cancelled is when the input action gets interrupted by something. But all we need to do is we'll do started here. So we're going to take our mesh out, and we're going to do play montage, and we're going to do started into here. Yeah, trigger is called basically every tick whilst you're holding the button down. Unless otherwise specified. Yeah, that's the default behavior there. So here we're going to do cast spell. I only want to do this once on started, so that's why I put it on started. And so let's compile that and make sure that's working. I can't recall if the slot is already done for us, but we'll soon find out. Nope, it's not done for us yet. So with a montage, your animation blueprint must have a slot to put the animation in. So it looks like the one they've given us in the third person template does not have this. So we're going to the animation blueprint, which is ABP Mani. And we're going to go over to the animation graph. Oh, we do have a slot. So why is it not playing? Okay, let's make sure. Cast spell, mesh, yeah. Right, we're just going to also make sure that this is print string that is saying something. Okay, where can you specify intervals for each time trigger is called? Sure. So in the things down here, you can go to the, I think it's modifiers. No, is it triggers? It's like a pulse. That's what that one does. as you describe it in there, Soul have. It allows you to set like no point. I ain't got anything. Oh, because of that. Yeah. So why can't this? Okay, so hello, cast spell. I'll make sure this is using the right slot. It should be, because I didn't change it, so it should be using a default slot. Yep. So we're using the right skeleton. No, it's not using the right skeleton. Okay. So let's fix that. Preview skeleton. Cast. Yeah, okay, so these are using the wrong skeleton. That's all. Right, let's just retarget this then. Retarget, duplicate retarget. We're going to use the retarget for the mannequin. And we want to use the one from the source, which is guessing that one. Let's see if that does it there. Skeleton, mannequin. Yep, okay, so that's now using the correct skeleton. So we should be okay with that. Let's just go back to our player character here and choose the right one. Choose that one. Compile. And push play. There you go. So I can cast a spell. Okay. So, that's all working. So the issue there was that it was using the wrong skeleton. That's pretty standard stuff that you get. Anywho, right, so let's create a basic spell effect for it to come out of its hands and so forth. Now, obviously, doing a whole gameplay ability system would be a lot better, but time is going to be an issue here, so we're not going to worry about doing too much like that. We're going to do a very prototype, basic thing of creating some basic spells that we could use and change the colour of. So we're going to showcase two things. We're going to showcase how to create this basic spell thing using a data asset maybe. And then we're going to showcase how to make the Niagara effect change its appearance based upon what type of spell it is. Okay. So let's go into a folder here for spells. And in here, we're going to create a blueprint class. And it's going to be a data asset. Data asset, primary data asset. Spell. Data asset. And in here, we're going to set up, so, yeah, I know, lots of things are looking weird on the animation. I don't get what's going on. But we're going to set up some information about the spell. So we have some couple of variables here, like name. That'd be a text. Description would also be a text. We'll have an icon maybe for a UI type thing if we get time to do that. Texture 2D. Another one here would be the type, which we haven't done yet. We'll come back to in a second. And also we'll do the effect. Okay, the ability itself, the thing that gets flung out and attacked. So we'll just do effect. Okay, so we have to make the type and effect as two separate things in here. So the type's an enum. Remember what I was saying about you matching the colors to different colors? So we need to make different ones for those, and we're going to do it via a enum. Data asset is basically like a data table. Yeah, it's a way of reading and storing data. You can't change it while it's in there, but you can read from it. It has a load of other little features and functions too, which is pretty useful. But I've got a whole video about it. Check it out if you want to learn more about data assets. So spell type, and I'm just going to keep it simple. We're just going to use colors. So we'll have red. I'll do 4 different ones. Red, yellow, purple. What other ones I have? It's just red, yellow, purple, isn't it? Yellow, purple. I'll leave it like that. Red, yellow, purple. I'll tell you what we'll also do is put a none on there as well, just in case we want to use that later on. I can envision us wanting to use something like that. So none on there. Okay, 3 types. So we're going to go to our type here and use that for that. Spell type. The effect is going to be an actor. This is going to be the actual class. That is the actual thing that gets flung out of the character. So we're going to make a blueprint class, create a new actor, and do spell effect. And this effect now is going to use a class reference to a spell effect. So it's not an object reference. The reason being is because an object reference is a reference to something that already exists in the world that you're playing. And the class reference is a reference to something that does yet exist. So we're going to go into a class reference there. Spell effect, which is the purple one. That'll do for now. We can always come back to this and add more to it, but that's fine as it is. Once we've designed your data asset, we can now create data asset files. So we can go ahead and create, in the miscellaneous section, a new data asset. When you do this, it's going to ask you for a blueprint of a data asset you want to use. We just made one called spell, so we go down to spell, DA. Select that. And now we can design each of the spells. So let's do a very basic one. We're going to keep it very simple here. We'll do fireball. That'd be a red spell. We'll just go into there. Fireball. Because I can't be bothered to remember the weird Latin names that Hogwarts Legacy has. Shoot, fire. Icon, not worried about. Type, we'll choose as a red one. And the effect we haven't made yet, so we'll go ahead and make one for that. And in fact, you could even just do it like here, click the little plus button. If you want a shortcut, you can tell it, place it somewhere. So spells, fireball, effect, and save that. Okay, there's a fireball effect. So we've got the fireball spell designed there. So let's create the fireball effect. Now for this, we're going to go ahead with the spell effect and add some basic common things that this will need. So all the spells in the game are projectiles. Essentially, they are flung out and at speed towards their target. And when they hit the target, that's when they do stuff. Okay, some are faster than others. Most are, I was going to say, not all of them are. Most are like that. There's a couple of AoE ones, but we'll focus on just the projectile ones. So on this spell effect here, we are going to add a sphere collision. Why do we want a sphere collision? Well, we want a sphere collision because that's the thing we're going to be using to detect hits. So we need something that we can do collidable assets on to do that. We call this a primitive component. So a primitive component is any component that has got collision settings that you can do on it. These we usually refer to models and meshes, but also things like collision spheres like this. And we also want to make this the root. So you drag it onto the root here and set it to be the root. Why the root? Well, when you're using projectile movement, the projectile movement and its collision settings are referring all the time to the root asset. So make the root asset the collidable. This is why your player character has the capsule collider as its root. Yep, because we use the physics on that root there. Same goes for our fireball spell effects. We want the sphere to be the root. Secondly, we're going to add a Niagara effect to this one. So we're going to go Niagara particle system and add it to the thing there. And that's going to be the actual effect of the spell, the sparks and stuff coming out of it. So lots of cool little things that we can mess about there. So that'll be fine there. And finally, we want is projectile movement. And as I said, the projectile movement by default is going to be very, very fast. So we can go initial speed here and set it to, let's say, 3000. Okay, max speed 3000 there. And just in case, we'll make sure rotation velocity is turned on. It doesn't really matter in this case because we're using a Niagara system, but it should be fine. Gravity, though, we don't want gravity to affect this. When it's a magical ability like this, we don't want it to arc down and hit the ground. It's going to be dead straight, whack and right at it. Hi, Game Mechanic. Hi, Moonstar. Hello. Hello, Noah. Hello, everyone. Okay. So we've got no gravity on it, which is perfect. Okay, and now we've got the Niagara effect on there. So let's create a basic Niagara effect. Now, I'm not going to create a Niagara effect for every single spell. We're going to make one and change its color based upon which one we cast, because I wanted to also show you how to accomplish that as well. So let's go ahead and do that. I'm going to create a new Niagara system. I'm going to create an empty one, and we'll do NS for Niagara system spell. And this is going to have a couple of emitters on it. The first emitter is it's going to be like a star-shaped thing that we want at start, which is going to be like the main body of the spell. Yeah, this little star thing. So we're going to go and create the new emitter and choose an empty one. And we are going to create a simple star shape. Now, at the moment, we've got a basic circle, a circle shape here. It's not what we want. So we're going to add a simple star shape. So for that, easiest thing, unless I doubt I've really got one in here, but I'll load Photoshop just in case. If I could just search for it, I guess. Star. I don't think so. Oh, gradient star. Hang on, I saw something. Right top. Gradient. Hold on. Star. Gradient star. I think there might be one that we could use. We'll see. Anyway, this one's going to have just one single particle on it that's going to last the whole lifetime of the emitter. So we're going to go to the emitter update, add a new update, and we're going to spawn burst. And we're going to spawn just one. Yeah, that's what I want, but I want to get rid of the black bit, obviously. So we're going to edit that there. Where is that? Material templates. Okay, we're just going to take a copy of that. We're going to edit it because it's part of the engine code. So I'm going to drag it from there into my content and make a copy and edit it. And we'll make this a translucent material. And I'm going to use the same thing here to opacity like that. So we should get a star gradient going on there. Okay, so let's see that now work with this one instead. Okay, that's not bad. We've got it just sitting there just fine. I mean, we could change some of the settings on here to make it a bit more fancy. But I think that would be fine, I think. Yeah, we'll keep it like that for now. We'll see how it goes. We'll see how it goes. Okay, so that's going to be the starting point. We'll make another emitter. And this one's going to be like leaving a shower of tiny sparks as it flies through the sky. So we're going to go ahead and create an emitter update here. And this would be a spawn rate. And the sprite render for this one is going to use the same star shape that we used here. So I'm going to go here, copy this, and go to sprite renderer and paste that in. Now if we go to the spawn rate here, I'm going to change this to quite a high number. Well, not quite a high number. We'll start with 20. We'll go higher if we need to. But there it is going now. But I want them to be left behind and moving through the sky, but also a lot smaller. So let's go to initialize particle, and we're going to go to the sprite size mode and go to random uniform, and we are spawning a load of little ones between 5 and 10 there. Not too bad. This one I might want to bring down as well. Go this normal style. Go uniform. That one's between 10. Yeah, I think this one's not too bad. Okay. Right. So the way this is going to work is that first star, the main star, is going to stay still with the emitter. Okay. Now for that to work, it has to use local space. So we're going to go to its first node up here and go to properties and turn on local space. That way it won't get left behind. We're going to leave local space though turned off for these ones, and what will happen is they'll be left behind as it goes forward, leaving a trail of stars as it flies through the sky. So that is how we do that. Now if I were to just to test this out, I can put this onto my projectile. Actually, I could put this on. I'll put it on the projectile. We're going to here, Niagara effect for the fireball, and choose my NS spell. It is. We might need to make it bigger, actually. It's a bit too small, isn't it? Let's make this first one bigger. Let's change that to 30. Like that. Okay. And then on my cast spell part of my character, we have the notify begin coming in. And this is because we put the montage notify on the actual montage, so that notify begin will fire off what we want to fire off here. In this case, we just want to do spawn actor from class. and we want to get hold of what spell we have currently equipped to that key. Now, for now, we're just going to have one spell on it. So we go currently equipped spell. And this will be a spell DA. It's referred to a data asset belonging to the spell DA data asset family. So I can choose Fireball from that list there. I can now drag that out. I can get the class I want to get the effect, and put that in there. The spawn transform is going to come from our player character. I'm not really caring about the hands at the moment. We just want to get from that point. So we're going to go spawn transform. We're going to get the mesh, and we're going to get the transform, and we're going to get the world transform. Put that in there. Okay, so hopefully what we should see here is the projectile is flying through the sky. This may be hard to see because of the size of it. We may need to tweak its size and brightness and things like that. But for now, let's see what happens here. So I'm on my controller, hold down my... I'm going to go to the darker area as well. Might make it a bit easier to see. Oh. I can see something spawning on the floor. Yeah, I see something spawning on the floor. Now, that's a good start. So the reason why it's spawning on the floor is because the mesh, its root is at its feet, and it was going the wrong way because the mesh is also orientated the wrong way. So we need to fix that, obviously. So what we do is get the mesh's hand. I'm going to get the socket transform. So the world transform of that. And we want to get the hand R, which is obviously the right hand. And we'll put that into spawn transform. Now, when you're dealing with sockets or bones, because they're interchangeable, the tricky thing is that some bones are orientated the wrong way. So I'm hoping the bone is already facing the right way, and we'll soon see. It's not a big deal because we're going to make it go to a particular way. It's just so we're testing it. We can actually see what the hell we're doing. Yeah, so you can see, I need to make it bigger because you see the stars hanging around. Yeah, we'll make it bigger. Because I can see it, but it's hard for me, and you guys have got like a stream to worry about, so yeah. So the uniform spell here, we're going to change this one to 100. Nice and big and bright. We're going to go to this one over here, and I'm going to change this one to between 50 and 80 in size. I'm also going to change their lifetime. So this lifetime here, we're going to go down, way down, to say 0.2. So they shouldn't last for long. They literally are like coming in and coming out. So we're going to go across here and push the button. There we go. Okay. So as I said, like, oh, we're using left hand there, so that's a little bit off. But you can see the spell going off just fine there. Let's change to the left hand. Where are we? There we are. Hand. L. There we go. This is the first live stream of UE5. This is the first and will be the only one currently, anyway, planned for. It's just going to be just a one-off. Let's create, see if we can do this thing. Obviously, I'm not making the whole entire game because that's kind of crazy. But we're just doing this one little thing to see if we can put it together and show how it's made. So if I hold down right trigger now and push the button. Yeah, see what I mean? Like the orientation of the bone is a bit weird. But I say it's not a big deal. You can kind of see it working. Because we're going to make it go towards a certain character anyway. Because we're going to do some sort of fake lock-on stuff. Okay, so we've got a spell going off. Next, we want to create a target that we can shoot. So let's create some target dummies. Different class, character, target, dummy. And go in here. I always like to use the yellow guy as the target dummy. Obviously, it's whatever. Target dummy. Okay, right. So I need to work out which one I'm locking onto. Now, this is quite difficult to do because every game handles it slightly differently. So do you go by distance to the center of the screen, or do you go by distance to the character? Because it's very different. And and it's not too clear what Hogwarts Legacy is doing, but it'd be interesting to see or hear from the developers what approach they took on it, or if I spent more time on it, maybe I could suss it out by looking at it. So we're going to do one where they are closest to the center of the screen. Okay. So, for example, if I'm playing here and I went to attack like that, the one in the middle would get attacked. If I'm like this, the one on the far corner there would be attacked, and one over there would be attacked there. So I'm going by based on how close they are to the center of the screen, not exactly in the center of the screen. It doesn't have to be like if I'm aiming over here, I still want to send my attack over to that guy. So we're still aiming to whoever is the closest to the center. So what we're going to do is first of all we have to determine which enemies are in our vicinity, which ones will be attacking in our vicinity. There's quite a few ways of doing this, by the way. As with anything in games, there's multiple ways of solving any problem. It's just a matter of figuring out which ones you want to do. So what we're going to do is do like basically get these certain actors within a radius of our character, and we'll use those to determine whether or not we are considering them for a battle. Okay, so we are going to go and do a very simple method. Don't have to do this method, but we're going to do a simple method and add a sphere collision around our character, like so. And this will be our targeting sphere. So we'd make this quite large. 1,000, maybe 1,500. It's quite large. You want it quite large. Okay. Okay. So, and you want to be doing this on a regular check. You want to see who you're targeting on a regular basis. Now you can do this on tick, but it's probably a bit overkill to do it on tick. You could probably put it on the timer and be just as good. So we're going to go up to our begin play and we're going to do a set timer by event. And in a new event here, we're going to create a new create event node. And we're going to create a matching event. And here it is. And this is going to be get current target. Okay. And we're going to make it so it does this thing on loop every 0.25 seconds. Okay. Obviously, you can tweak this to whatever you want later on. Okay. So on our get current target, we're going to take the sphere out and we're going to get overlapping actors. And we're going to choose our filter here, in this case, target dummy. Now, if you've got an enemy class, you normally are using your enemy parent class in this instance. So we're doing that. So target dummy, there. And that gives us all of them here. Now, this hopefully shouldn't be too many. You don't want to be facing, don't want to use this system if you've got like a horde of zombies around you, because that's way too many to deal with. But if you're dealing with like 10, that's fine. It's when you've got hordes and hordes and hordes, you don't want to be doing this system instead. But it kind of makes sense why you don't want to do that system for a horde of zombies, because we're going by the center of the screen. So they could be like slightly off center. But if you're surrounded by loads of things, you might best sticking with just going to center, which is a lot easier. How about a sphere traced by a channel? You could do, but it'd be a lot harder to get those sort of ones in the corner sort of thing going on there. You could also do a multi-sphere trace. Yeah, as I said, there's multiple ways of doing it. A multi-sphere trace and getting them like how far away they are. You just got to do a very large multi-sphere trace. Totally can do that. Yeah. We'll be able to watch this later if we missed it at the beginning. So this live stream, like all my live streams, are available to Patreon members straight away for 2 weeks, and it's available to everyone else after that. So if you want to support the channel, if you want to support the channel and get access to this video, plus many other things that we've released on Patreon at the moment, just $1 a month will get you access to all of it. So that's fine. Yeah, get overlapping actors from there, and we'll do for each. Actually, I'll tell you what, so hey, I'm actually going to do a multi-sphere trace by channel. Actually, I think, yeah, we'll do that one. I quite like that idea of doing that instead. So multi-sphere trace by channel, or by object makes sense actually, rather than channel. Multi-sphere trace by objects. Start point will be our camera manager, and we'll get the actor location of that. And on the end here, we're going to do get forward vector of our player camera manager, and we're going to multiply it by a length, and that's how far away you want to be able to check. So convert float, and we'll do 1500. Well, let's do 2000. Okay, so quite far, and that'll go added onto the actor location here. So the radius thing, this thing has to be quite large, because you want to try and cover as much of the screen as possible. So we're going to do a radius here of, let's say 500. Okay, so it's 500 that way, 500 this way of the character. And the object types, we want to drag out here and do make array, and we just choose pawns only. Okay, it's going to ignore itself, obviously. That way, we're only going to register any pawns, or in any pawn really. Only. So it does that, and we're going to get all of them out of here. And what you can do on this one is just get the first one. The first one's going to be the one that's closest to the player. We'll get you the first one. But if you want to go to the closest on the screen, that's slightly different. So we're going to do a for each loop on this. And break open this result. So now we've got information about each of those hits. Now it's now a point of measuring their distance from their position to the center of the screen's position. So we want to probably line trace by channel. We'll do, what would be best to do it before or after? Probably I need to do it once really. You've done one Niagara effect already, yeah, Skull. We'll do some more maybe if we get time. I'm actually going to do, what would be the easiest way of doing this? You want to do, let's do it at the start here. We need to work out where the center of the screen is. So let's do line trace. Oh, hello. There's distance. Yeah, distance is only work. So distance would work fine if we're going by how close they are to the camera. But we're not going by how close they are to the camera. We're going by how close they are to the center of the screen. Okay. So if someone's closer to us, but someone else is like more aimed in the center of the screen, that's the one we want to target. So you have to actually aim your camera at it rather than get someone close to you. That's what we're trying to do here. So we want to get current target, and we want to do a line trace by channel. 4 objects. We'll do 4 objects here because we want it to ignore everything. So the start point here again will be camera manager, because we're going for the center of the screen here. And in fact, we'll just do the same. I think it's exactly the same settings here. Copy that. And we'll put that into end and that into start. So exactly the same sort of settings here. But I'm going to leave object types blank, and that should hopefully be all right. Okay, so that's going to get us a big line going right down the middle. What's important for us then is to measure the distance. Oh, what do I want to do? I want to get. I'm going to get paint out. Help me understand this. So if our camera is there, we've got guy here, guy here, guy here. We're going to have a line trace going down the center of the screen like this. And I need to measure the distance between their position and the line trace to work out which one is closer. What are you saying? So I have forward vector of player camera manager dotted by the camera manager minus hit actor location normalized. Store all values in a float array and get closest value to 1. Forward vector of player camera manager dotted by the camera manager minus hit actor location. Oh, okay, so the camera location minus the hit actor location normalized. Yeah, would that work? We'll try it. If we take this here, yeah, get player camera manager forward vector is which way they're facing, and you're saying you want to take the location, from the player camera manager, subtract from that the location of their position, and dot that and that. Interesting. Okay. Okay. Let's take that out then. Okay. Trying to work out the math behind it. So the actor location, subtract their location. Oh, normalize it. Yeah, sorry, forgot to normalize it. This is why I usually have my pen and paper out to work out the maths. I'll tell you what we can do. We can do print string on this to print out their distances. Print string. We'll do the append string. And we'll take the name of their hit actor. And we'll take the... add another pin here. And we'll do equals that dot product there. Okay, and so we've got... oh, okay, I don't want that many. We should only... oh, I'm not moving, so it should be looping. Test dummy 2 is 1. Test dummy is -1. I'm not seeing any other test dummies being called up. Test dummy 1, 2, 3. Why are we not getting any more than that? Oh, he's probably not. He's not in range. Okay, so test dummy -1. -1. No, that's not right because they're all turning out -1. I like the thinking now behind it. Oh, I don't need that anymore. In the meantime, we'll go back to doing this method. Try. Can we edit the original game? Like, no, of course you can't. You can probably mod it on PC, but you're not allowed to. You want to flip the minus. What, the other way round? I mean, like put this on the bottom. Yeah, sure. 1, 1, 1, 1. No. No. Double check what you said. Hang on. For the player camera manager dotted by camera manager minus hit actor location normalized. Yeah. No. Yeah, that's right. Yeah, normalized. Yeah. I like that thinking though. Let me get my pen and paper out and see if we can use dot product to help us with this. Hold on. Draw little diagrams. So let's say my camera's position here is 50 by 50, for example. So when I'm working on paper, I'll use like, I'm literally just drawing things. I don't think you can see that at all. And then I'm plotting like a basic graph, and I'm drawing on here like a basic coordinate system. So if we were to take this logic here that we've got so far, where we've got the camera actor location, which I'll say is like 50 by 50 in X and Y, minus the location of the actor. So let's say the actor is at 100 by 100. Okay, so here I'm taking the actor location 100 by 100 minus the camera's location, which is 50 by 50, and normalizing it. I mean, the normalization part of the location is the weird part, because you're taking a location and then also a vector, which is odd, a direction vector, which is odd to do normalization of that. On Discord. Oh, hold on. Yeah, I've got Discord. My phone. So I'm intrigued to see how you're doing it with dot product. Oh, you DM'd it to me, or you put it on the general probably? Normalization squashes a vector down to so it's a length of 1 only. So if you're doing like a directional vector, you get a velocity, you can just normalize it down to get the direction from that velocity vector. For location, though, it's a little bit weird because it's just going to squish it down. So if it's like 50 by 50, so location, it'll go just down 1, 1. You can get the angle between the camera forward and look at them. Look at the camera to dummy location. The smallest angle will be the closest to the screen. So, oh, that's an interesting way of doing it. Yeah. I like that method. That's quite a nice one to do. Okay, let's do that then. I quite like the angle method. That's an interesting way of doing it. So, yeah, we're going to get the angle between the camera vector. Oh, I should delete that. I'm normalized because forward vector is normalized. Yeah. Can we create mods? I honestly don't know. You have to play. I have no idea about the game. You have to check it out. I don't know if it's officially supported. I don't doubt it. Because they're quite protective of that stuff. But people are modding it. Get the forward vector of the camera. And I want to get the angle between 2 vectors in here. So we want to take get the direction between the camera manager and this actor here. So get actor location, direction, get unit direction between the camera to this location, and it gives us those 2 there. And I know it'd be cosine. So cosine angle 2D. I think that's right. That should give us this. And then we'll do the print string again to work that out better. So print string, the vector cosine. Thank you for the suggestion for angles. That's an interesting method of doing it. I've never thought about doing it that way. It's neat. Yeah, I think that's right. No. Vector cosine returns the cosine of the original angle between this vector and another projected onto the xy plane. No z. Yeah. That should be right. The xy plane is this one, which is correct. We don't care about height. We got the angle of going this way, got the angle going off this way. And if you know, if you've done from school like SOHCAHTOA, where cosine is the adjacent hypotenuse, that's your hypotenuse, that's your adjacent. Yeah, adjacent. You want that angle there. You take those positions. So why is it not doing that? Get to location of the camera. Location of the actor. No. I'll double check. I'll just do the actor location of this instead of that. It should be the same, but yeah, that should be right. Cosine angle, yeah. Oh, there you go. Okay, cool. We are getting numbers. Excellent. Okay, so we need to work out which one's the so it gives you like in a radians, I believe this will return. So if I do the a cosine in degrees, this outputs in degrees. So if you ever wonder what it is to do in degrees, it should give you that. So, oh, hello. If I do print string, and we get the actor. Actually, let's do a pen string first. Be quicker. And God's sake, string. Oh, there it is. Hit actor in there. Space equals space. Add pin. Angle in there. Okay. So target dummy 1, which is the one I'm looking at directly, has 0.85 angle, where dummy target 2, which is the one on the right there, it's got 11 degrees angle. And that one on the left there has got now 10 degree angle, and the one on my right here has 9 degree angle. And now it's got 13, 14, 15. Excellent. Okay, that works perfect. Thank you. Whose suggestion was that? That's a good example. Tuffel Honden. When you create a new project and it goes at the bottom, you click the new way you want to save it, and you go choose a C drive, what happens next? Does it give you a warning still? And the second to that, is your OneDrive syncing everything in your C drive? But yeah. Okay, so we just need the closest value. So we've got that. We're just going to store these in an array. We could probably put all this into a function as well, actually. We'll take that and collapse that to a function. And in here. Okay, right, so I'm going to take this and we're going to store it in a map so we know which one is closest and their values. So we're going to go, or not a map actually, we'll just do 2 local variables. The first local variable will be an actor value. The second one will be local angle. That'll be a float. You can't see what I'm typing, I know, sorry. So I've called one local angle, and the second one here I've called local actor. So I'm going to store which one was closest and which one has got the smallest angle. dynamically. So as it goes through each one, local angle, by the way, I want to make that quite large. Let's go 90. And for each one, when you work out the angle, if this angle here is less than the current local angle, then that means that this current actor is now the closest actor to the center of the screen. So we'll just bring that up here. And, oh, hello. And store the local actor here on true to the hit actor. And we store the local angle to the cosine of the two vectors. And so it will go through each hit actor and return the local actor. So once it's finished going through each of those for loops there, we're going to go completed, go down, and we're going to do a return node. And we're going to return the actor that we are currently targeting. And current target, we'll call it. Cool. Right, we get current target out of here. Now, to help us identify this, I'm going to do a little, like, arrow targeting component here. Or I'll put a sphere, actually, on them. I'll do a sphere. I'll just change its collision to have nothing on it. No collision. And I'll just say sphere, set world location to the location of this actor. So it's going to move the sphere over so we can easily identify and see this happening. So when I push play now, there's the sphere. It's now picking the ones that are closest to the center of the screen. Smooth. Okay, so we've got that down. So next we need, just a visual thing to show you that's working. We don't actually need the sphere. So what I need to do now is make it so when I come out of there, we're going to store the current target here to a value, right to value, and this will be current target. And if we are attacking, when we go to start here, we are going to check if current target is valid by right-clicking, convert to validated get. If it is valid, we want to take the current target and we want to turn our character towards it. Now, our character is using the control rotation to turn, I believe. Or they're using movement. They're using movement. Okay, we're going to use... I'll just change their position. It'd be easier, time-wise. So you can get actor... set actor rotation. And put that in there, and we want to split that, and we want to get the look at rotation of this. Yep, you get actor location first. Look at rotation. That'd be the target. The start is our location, and we're gonna split this and just affect the yaw. We don't want to do anything else, just the yaw. Do that. I think I had to play here. Okay, so if I go to push my game, oh, let's go with that sphere now. Just get annoying. Don't need it now. Okay, so push play. Turn my controller back on. It's going to work. Might have to stop it and play again. There we go. Right, so if I right click and shoot, he should turn to which one he thinks is closest. Okay. Okay. So now I need to make the attacks go towards them. At the moment they're just going by the bone angle. So if I go to the attack, which is going on here, so rather than getting the Tocket transform, we're going to get the look at rotation, which I'm actually going to do here. I'm going to break this open, or make it rather. Make transform. The location is going to be our mesh's get socket location and L and put that onto location. The rotation though, we're going to go from here. So I'm just going to break this open actually first of all. Recombine that, drag that over to here, and then I'm going to break it open in a separate node so I can just use the yaw as is there. Okay. Right, so hopefully we see our spells going towards our characters. Might need to make them a bit more obvious, but yeah, I need to make it more obvious. Okay, so it's always going to that one. Oh, there we go. Cool. Okay, so it works. We just need to. I need to make it more obvious so you guys can actually see it. So let's go to my Niagara effect here. We're going to change the color of it in a user parameter. So in user parameters here, we're going to go into here, make new, and we're going to give it a color and do linear color, and this would be spell color. So over on our particles here, I'm going to do a very simple thing where I go into my particle spawn and set color. And I'm going to set this to my parameter. So I'm going to type in here spell color. There it goes. I'll do the same for this one. So I'm going to copy this, do it spawn over here too, and compile and save. We'll then go into. I'll make this actually spawn a lot more. We'll do 100 of these been spawned in. Okay, and let's go back to our character. Okay, and when they spawn in, we want to set what class they are. So at the moment, the fireball effect over here, we're going to set up their data asset on here too. So on the variables here, we'll call it data asset, and we'll do spell DA, and we'll set that to the one that's associated to this one, fireball. So on the construction script for this one, I can take the Niagara effect, and I can set parameter, and I want to be careful because when you do set parameters by default, it will go to the audio section. Done it many times. Don't do that. You want to go to the components for the particle system and do set color parameter, and we're going to do spell color. And what I'm going to do with this parameter here, drag it out and do switch. Not switch, sorry, select. Set color. Not that one. Select and do the other one. That one there. And in my data asset, we've got that type enum. And from there, I can get the spell color. So get type, plug that into here. We've got none, red, yellow, purple. So red, obviously you're going to make red. Yellow, we'll make yellow. And purple, we'll make sort of like this sort of color. Okay. And hit compile. So, let's see if that works. We'll go here. Not so much. Why is the color not changing? Did I spell it right? Spell color. Yep. Fireball effect. Data asset. Fireball. Construction script. Spell color. Yeah, that's right. None. White. Oh, did I not set it? Hang on. Did I not set it on the fireball? Oh no, I did. Red. So why am I not getting that coming through then? And let's just do print string there. and print string this type. Work out why that's not happening. Yeah, red. Okay, so it's getting the value right. But the particle spell material, I don't know. Oh, yes, thank you. I forgot we changed that. Yep. Oh, okay. Particle color. Thank you for that. So yeah, we need, in order for material to receive color from particle system, you have to have this node, and we're just going to multiply that by the power there. Okay. Now that should work. There you go. Okay. Now, if the rotation, so if the current target is not valid, we just want to use the straightforward direction of the character. So if I go into my player character, and we've got this as not valid, we still want to do all this stuff. We just don't want to change the sector rotation. So it's not valid here. We'll go across to play montage and skip the rotation setting here. But the value for the rotation here will be different. So what we're going to do here from this rotation is we're going to do a select rotator. I'm going to drag out my current target and get is valid. And put that into there. If it is valid, it's just the same as we did before. So that's A. But if it's not valid, B, we just want to get our current actor's rotation. So get actor rotation. And put that in there. So if we haven't got a target because we're not aiming at anyone in particular, he should just shoot forwards based on his position. Like that. But if I go here, he'll lock on to previous target. Yeah. Okay. You made a C drive folder called UFN test folder. It's not backed up by OneDrive, and it says it already exists at this location when I try to make a new template. I'm not entirely certain why yours is doing what you're saying it is doing. If you want, email me pictures or video of the issue, and I'll tell you what I'm seeing. But what you're describing doesn't make sense too much. Oh, hold on. I messed up that bit. If it's valid, do that. If it's not valid, yeah, that should be right. Why is it thinking that's weirdly not valid? Anyway, I want to move on to a shield because we're out of time. So to make a shield effect, ecosystem, create system. Actually, we don't need an ecosystem for this. We're going to create a blueprint class, actor, shield, and in here we're going to add a big sphere, and the sphere is going to have no it's not going to block all dynamic. We're going to just make it so it overlaps everything. When we have that there, we're going to scale this up so it's nice and big, 3 by 3 by 3. Send me a DM on Discord, it'd be better. Okay, so to create the shield effect, we're going to create a simple material. But this is also going to be affected by a variable, which is the spell color. So we need to have a Fresnel node, or Fresnel, I don't know how you pronounce it. And we're going to multiply that. Multiply by color. Shortcut is 3, left click by the way. Convert to a parameter, color. And we'll put that in there. And then this will go into emissive color. This will need to be translucent, so we're going to change that to translucent, and we're going to use the Fresnel here to the opacity. Okay, and you get this effect. So if I were to change this to red, for example, it looks something like that. Yep. And if you want to change some of the settings on the film, that will change the effect you're seeing here. So, for example, if you change the exponent here down to 1, it covers up more of the area, which I kind of like the look of that. That's quite nice. And then the base reflect fraction takes how much of that edge is going to be used. So it's quite a small number, this one. So 0.02, you don't want to go much higher than anything like that. Because if I go to like 0.1, or 1, there you go, it comes like that. So 0.05, oh, I don't know, it'll do, we're not fussed about that. So colour, that's what's important. Okay, so on the shield here, we're going to go to the construction script, add a variable to this thing, and that'd be shield type. Now use our spell type, so spell type. And on the construction script here, we're going to take the sphere out. We're going to do create dynamic material instance and choose that material we made. So shield M. And in here, we're going to do set vector parameter and choose our color. And this will be the same as we did for the spell effect for the fireball, this thing here. We're going to take the exact same thing and copy that. I'm going to get rid of this now whilst I'm here. And put that here. And the index for this is our shield type. I don't know. Okay. Okay. So, yeah, that'll do that. That'll do that. And then we need to assign that material back to our mesh. So we go sphere, set material to that material there. Okay. So for example, I made that editable. So if I was to take that sphere shield here and put it on the enemy here like this, I could go. I did unlock compile it. No, there we go. If I go in here and change the type here to red, it will change to red, yellow, purple. Okay, I can change whatever color I want there. Okay, so we can do things like that. Now, we want the enemy. Oh Christ! Oh, it's not a bit pick it because it's see-through. Okay. Yeah. So there you go. So we want the enemy to spawn this shield on them. So the target dummy here. We'll edit. And on begin play, do spawn actor from class. Choose the shield. And we want to set the shield here to a color. So what we do is make this shield type here expose on spawn. If I have it set to expose on spawn on my target dummy, I can refresh this node and I can see the shield type here. I can choose what shield type I want. So you can make it so certain classes have certain things if you want. Up to you. So spawn transform will be the actor transform. And then we want to attach it. Attach actor to actor. So target is the shield, parent is the self. And with the location rule, rotation rule, and scale rule, you can leave this to keep relative because we're spawning on our location anyway. If you want, you can also do it to keep world if you want. Oh no, we don't. We definitely want to keep world. I think it doesn't really matter. Keep world, be fine. Okay. Yeah. So we just say that, for example, if we change that to red, and when they spawn in, they should come in with their red shields. Now we'll make it so when our spell hits it and it's red, we'll make it check for that effect. So if I go to that shield again, and we do active begin overlap, cast to spell effect, get the data. No, what do I call it? Spell effect. Oh, I don't know if I put it on the wrong thing. It's bollocks. Hang on. Cut that from there. Yes. And paste it on here. Compile that. There you go. Yeah, back on the shield. We get spell effect. Get data. Asset. There you go. And then from there I can get the type of the thing that's hit me. If the type of that is equal to my shield type, I'm going to do destroy actor. And I'm going to do another destroy actor. Well, in fact, what I can do is just destroy actor this spell effect and also self. So it takes both of them out. Okay, so yeah, if I go into here and now if I shoot one of these with my spell, it destroys it. So I can now do different effects. Okay, and let's say we change it so they randomize which shield they have. So if I go back to my target dummy and shield type here, we'll do random. Yeah, a random array item. I'll just do make array. Be fine. Red, yellow, purple. Like that. There we go. That'll do. So the purple one should ignore my spell. Okay. She does. But the red ones, she'll take my spell. Yeah. And that's about it. And that's the prototype of that setup. So these characters will spawn these shields, and those shields will be attached to them as they walk about. And your different spells you'd use have different effect colors and effects on them. So using the data asset, we can use the enums to compare them with our shield types to get rid of shields or otherwise. And if you're doing something like if you hit the shield wrong with the wrong color 4 times in a row, like it does in Hogwarts Legacy, and it stuns you back or sends it back to you, the shield can keep track of how many has been hit by it. So you can you can start seeing from this point where you could go further into creating the Hogwarts Legacy style combat relatively simply. Okay, so let's look back on what we've covered here. We've covered how to do compound. What do they call it? Like compound triggers. So you have to hold down one button while you put another one in. What the hell do they call that? I can't remember what they call it now. Third person input attack. Corded. It's a corded action. So it allows you to shoot, hold down a button and push a button to activate it at the same time. Went through basics of some Niagara system stuff. We went through how to play a montage and to make it shoot something out at that projectile type thing. We went through how to set up an enum with data assets and create spells. We also set up the shield system and how to make a shield check what's hitting it, if that effect there is matching its own effect, and if it is, they neutralize each other. Otherwise, they'd be ignored. So lots of cool things covered in this single live session. Now, if you like what I'm doing and you want to see more content, there's plenty more to come. On Patreon this week, we started doing a series of pushable blocks. So a lot of people have asked me in the past, how do you make it so you can push a block around and then climb it and things like that. That's started coming out now on Patreon. It's 4 episodes long. They're coming out over the next 2 weeks, I think they are, along with the project files. The quest system is about to finish up on Patreon. The quest system files are complete and available to gold and higher patrons on patreon.com/RyanDaily. The Unreal Editor for Fortnite series is continuing. There's loads more episodes to come. 2 have been recorded and being edited right now. I'm recording a few more after this live stream. So a lot more of that coming, including introduction to Verse, their new programming language. We talk about that and how you can start learning how to program using Verse. There is all sorts of cool stuff coming out over X amount of time, and I've got some super cool surprises coming your way very soon. I can't wait to share them with you. But don't forget, we do also have a Spring Game Jam coming out soon as well. If you want to sign up to the Spring Game Jam, all you have to go to itch.io and search for Ryan Laley Spring Game Jam, and you'll find it and you can sign up to it. Sign up to it. The winning prize is $200. So if you are a winner, you get that prize money to share amongst your team, however you wish. But I'm going to say, otherwise, a massive thank you to all my Patreon members for their continued support. If you're a Patreon member, you can look forward to the live stream being uploaded to you straight away after the live stream. Everyone else on YouTube, you'll get it 2 weeks later, so don't worry, it will be out soon for you guys to rewatch back again and again. Thank you so much for joining me. If you want to see more live streams, we do one every Saturday and every Wednesday. And on Wednesdays, you can expect question time, where you can bring any question you like regarding game dev, Unreal Engine, or whatever it is you want along for the ride. And lastly but not least, on Thursday the 30th, I will be in London for the WASD exhibition, where I'll be going around, meeting up with people, checking out games, and just hanging out generally with everyone there. So if you want to come up to me and say hi, you're more than welcome to. I'll be down there on Thursday all day long, hopefully. So yeah, feel free to say hi if you want to say hi, grab a drink, whatever you want to do. Always good to meet up with people who watch the channel. So thank you again for watching. If you haven't subscribed yet to the channel, please hit that subscribe button. And if you want to support me, head over to patreon.com/Ryan Laley, and you get access to all my content early, plus many other benefits coming out now and also coming very, very soon. Can't wait to share it. It's going to be awesome. But thank you so much, everyone, and I'll see you all next time. Good night, everyone. Bye.
Yeah. Yeah.